Hi guys, back to more absolute value type problems. We've been talking about absolute value equations, and we are about to go into absolute value inequalities. So back in 3B, we talked about and or type inequalities. If you want to check your notes back on, that would be 56, we had or type inequalities and type inequalities. We're following up on that same logic, but now we're adding the absolute value sign, which complicates things a little bit. So I think I'll be doing this section in 2 videos. We'll see how far I get today, how much I think you can absorb at one time. So I'll come back to this land of Gore up here. I'll talk to you about it in a minute, but I kind of want to review what absolute value means. Absolute value, of course, comes out as positive values. So when we're looking at this absolute value right here, let me get to this page. Actually, I think we're on page 61. The numbering appears to be off on this particular paper. Anyway, we're at the top of page 61. This means the absolute value less than 5. It means that the points that are true for this inequality is less than, all the points, less than 5 units from 0. Because if they're -5 or -6, they also come out as a positive value. So we have to consider both the positive and the negative values. If the absolute value of x is greater than 5, we assume that the point that we're looking at is greater than 5 units from 0. So when we are graphing these absolute value inequalities, we have one of two things. We've either got a less than symbol or we've got a greater than symbol. We are going to treat them differently. So this first one says all the points distance from 0 is less than 3 units. So if we look at this graphically, all of the points on this number line that are less than 3 units from 0 are these guys. All these guys in here. Whoa. I'm going to erase and start that over again. Maybe even with a different color. So how we write this algebraically is with an and type inequality statement. -3 is less than x, x is also less than +3. This is an and type equation. If you need to go back to 3B and look at those, stop the video now, go back, look at your notes, and come back in when you've refreshed your memory. This guy says the absolute value of x is greater than or equal to 2. Greater than or equal to 2. His distance then from 0 is greater than or equal to 2. So if I were going to show all the points on the number line whose absolute value distance is greater than or equal to 2, I would be looking at all of the points going this way from 2, including 2, but also -2 going this way. Because if we put these points inside an absolute value symbol, that turns them positive. So this might remind you of an or type statement back in 3B. Their graphs look like this. The and graphs look like this. So algebraically, the only way we can write this is greater than or equal to 2 or less than or equal to -2. There's no way to combine them in a statement like we did up here. So when you are solving these absolute value inequalities, let's go back up here to the land of Gore. When you have a less than symbol, like right here, less than symbol, you are going to use an and type inequality. you're going to solve it and have an and type answer. When you have a greater than symbol, like in number B, you are going to have an or type answer. So that's what the land of Gore is. L, looking like less than, or standing for less than, means it's an and. If it's greater than, it's an or. So there's a couple real special situations that you always need to look at. If you have the absolute value of x set equal or less than some kind of negative value, it's not possible. So the inequality has no solution. So for instance, if I said the absolute value of x is less than 0, that means it's a negative number. And there are no possible solutions for this inequality, because anytime you take something out of an absolute value sign, it's either 0 or positive. So it's greater than or equal to 0. So absolute value of x is greater than or equal to 0. Well, that's all real numbers, because every single value that you put in for x is either going to be 0 or it's going to be larger than 0. So these two are really kind of some special absolute value type problems, and we'll work a few of them down the way. Okay, so let's look at this one. Actually, here's one right here. I think both of these are two examples of what we just talked about up here. So tell me all the numbers. This is saying, tell me all the numbers that you can possibly put in here whose absolute value is less than or equal to 0. Well, there's only one number that's going to work, because there are no numbers less than 0 that come out as a positive number. So x is equal to 0 is the only solution. Only 0 is less than or equal to 0. If you put in any other number in there, you've got a number that's larger than 0 because it's positive. And this one, it says, tell me all the numbers that you can put in here for x that are greater than or equal, will come out greater than or equal to -2. Well, they're all going to come out greater than a negative number. So this one is a no-brainer. Your answer is all real numbers. So those are kind of some exception things to look for when you're solving them. I think I'll end this video now, and we'll begin on page 62 in the next video. Thanks for listening.